So our next speaker is Kory from iRODS, and he's going to tell us more about the multi-protocol support in the iRODS ecosystem.
All right, thank you. Happy to be here. Again, my name is Kory Draughn. I'm the Chief Technologist for the iRODS Consortium. I'm going to be talking about protocol plumbing with iRODS. All right, so first off, a bit about the consortium. It's an organization that is operated out of the Renaissance Computing Institute. This is one of many research institutes at the University of North Carolina at Chapel Hill. Here we have a slide showing many of our members who make up the consortium. These are people doing science, integrators providing tier 1 support and various other things, as well as software vendors who are looking to sell into these locations. All right, so the consortium's goals, missions around the iRODS software is that we want to provide continuous improvement around the software. We're looking to grow the community, provide standardization, as well as we want to show value to the people who join as a member. All right, so I guess a bit about our business model. You know, this is more of a sustainability model around iRODS. The software is completely free and open source. Everything we do is in public. But most people who tend to use iRODS, they end up looking to join as members because they need the software to be around for a long time. And there's various levels to membership. With this, you get support hours, access to developers. We can do proof of concepts, etc. If you have more questions about it, please find me. iRODS has been around for a very long time. It's been around for more than 20 years. We've seen about 44 releases since the initial release. So why do people actually use iRODS? Well, it turns out that if you have large amounts of data that is spread across various different storage technologies and you're finding this hard to manage, this is one of the reasons why people come to iRODS or seek a solution that can simplify that situation, as well as providing controls around access to data, whether it's reading or writing, providing efficient search capabilities, and automating things around your data. And the larger your organization is, the more you need software like iRODS. All right, so here we have a graphic showing where iRODS sits in your software stack. iRODS provides an abstraction layer, which enables flexibility for your infrastructure to change over time. So if you're running iRODS, typically all of your software is communicating with the iRODS layer, and therefore your users and your other systems that need to access this data go through the iRODS layer, and they don't have to worry about what storage technologies or things are happening underneath. All right, so iRODS provides these things called capabilities. I'm just going to briefly talk about these just a little bit. These are packaged and supported solutions which have been developed as use cases and issues have been seen throughout the community. So things such as storage tiering, indexing, audit, like ingest. We provide packaged and generalized solutions that allow people to just simply install a package and configure it, and then they're set. This kind of just builds off of the last slide here. Normally, people who come to us, they typically want one of two things. That could be, you know, they want indexing or storage tiering. But with that, they tend to expand to other areas that they need, such as publishing or auditing, which can lead to needs around compliance or provenance and things like that. All right, so for the meat of the talk, protocol plumbing. What does this mean? This is all about providing shims around the iRODS protocol. So iRODS implements its own protocol, which can be a bit unfamiliar for people. And so what we'd like to do is we've been spending a lot of time over the years providing ways to present iRODS as different protocols so that people can take advantage of their existing scripts and tools and interact and gain access and visibility into an iRODS deployment. So In this talk, we're going to cover 7 protocols or seven different projects that implement and present iRODS in various ways. Here, again, the idea is that we take some familiar protocol that people use and we translate that into various iRODS API calls to provide an experience that is familiar to most users. So first up is WebDAV. So out of the University of Utrecht, they've developed a project called DAVRODS, which presents iRODS as the WebDAV protocol. And so this is written in C and implemented as an Apache HTTPD module. So you install this and configure it, and then you're able to mount and expose iRODS as a WebDAV interface. Next is Fuse. This is a project that is developed and maintained out of the University of Arizona through an organization called Cyverse. They implement various different tools and things that they use throughout their organization for thousands and thousands of users. This allows iRODS to be exposed as a Fuse mount, and this is all written in the Go programming language. One thing you'll notice here is that not only is the consortium developing software, but our community is also developing software on top of the iRODS platform, and they write these things in various different programming languages such as Go, Java, C++, C. This is the 2nd generation of the Fuse implementation. They had an older version which had some issues, but now they've re-implemented that using Go, and it's much better and showing a lot of promise. So as for REST, the iRODS Consortium is developing a REST interface for iRODS. Again, this is our attempt at simplifying access to iRODS systems. Most people, again, are not familiar with the iRODS protocol, and we don't want to force people to have to learn it. We really want to get away from, we want to make things as simple as possible, and REST has taken over the world, so it seems like a very obvious choice to provide a REST interface for interacting with iRODS. This is written in C++, and this too is the 2nd generation of the iRODS REST API. It was originally written in Java many years ago, but now we've developed better C++ interfaces that allow many of the operations in iRODS to be done fairly efficiently and easily. All right, so NFS, this is another project that the iRODS Consortium has developed. This allows iRODS to be presented as an NFS 4.1 mount point. And so this is written in Java using the NFS for J project. We've implemented a virtual file system implementation that allows it to run alongside an iRODS server. You configure it and point it at different locations within your deployment, and it will expose that and maintain users and provide and honor the iRODS permission model as you execute operations. So this gives people a way to interact with the iRODS system and access data without them actually having to know that they're actually talking to an iRODS system. All right, so SFTP. So out of Cyverse again, they forked the SFTP Go project, which by itself already provides support for various different storage backends. But what they've done with their fork is that they've implemented a Go module that allows you that exposes iRODS as through the SFTP protocol. And again, Cyverse is using all of their tools within the production environment, and everything is working really good for them. Next up, again, is another project with Cyverse. They've implemented a CSI driver. If you're not familiar with CSI, this is a container storage interface. And so if you're running things that support the CSI driver, then such as Kubernetes, then you can provide access to your iRODS deployment. You can provide access to the data that's stored and managed by iRODS to your containers that are managed by various different container orchestration engines. Our last protocol here is S3. So for many years, iRODS has supported being able to communicate and interface with S3 storage systems. But we've now basically flipped everything on its head, and now we're trying to present iRODS as an S3 endpoint because there's users who wish to communicate with iRODS itself as an S3 interface. And so this is in very early stages, but we are hoping to have something available soon. And yeah, this is what we're hoping, that people try this out and then it comes out really good. So what have we learned through this process? Shims are not perfect. There's always something that doesn't quite align with things. There's also trade-offs, obviously, right? iRODS provides several different features, but because we're trying to present it as different protocols, you're limited to certain things. Therefore, like, for example, with NFS, you don't get access to metadata. But, you know, people who run NFS, they obviously know this, and so it's acceptable for them in their environment. This is also, and even though they're not perfect, there's still value in doing this, right? Because protocols tend to not move very quickly. They tend to be relatively stable, and so once you do implement these things, there tends to be very minimal maintenance around having to change things, right? As for future work, we are always looking to add more protocols or ways to present iRODS and make it easy for people to access and use. We want to continue to improve the implementations, the existing implementations, and make them stable. And we're also considering, depending on how the REST interface performs and is accepted by the community, we're looking to have that absorbed into the server itself and just provide it natively, making iRODS even easier for newcomers to use. So last but not least, we have our annual user group conference coming up in June. This is a place where people in the community come together and they can talk about iRODS and ask questions, see presentations and how people see success stories, challenges that people are facing while using this software. Here we also offer training and troubleshooting sessions. If any of the things that I've mentioned during this talk sound interesting, you can come and find me, or you can just find all the things that I've just mentioned online at iRODS.org. And with that, thank you.
Thank you. Are there any questions for Kory? Well, over there.
Thank you. So with all these different ways to expose iRODS, what's the performance hit, or basically that you take on the different sides?
I don't actually have performance numbers for you, but obviously while introducing additional layers is going to slow things down, right? But that is one of the trade-offs that you have to consider while, you know, with introducing these shims in front of your software, right? The people who use iRODS aren't typically concerned with major performance issues in that way, because they typically need things to just be stable, and they want to make sure that things are consistent more than anything. They don't want to lose data, and that's mainly the most important thing. Now, when you have multiple users, then when you have several thousands of users, that might be a different story, right?
Are you targeting more like a federated approach, or inside of the same organizations?
So iRODS provides support for federation, and so like two different organizations, if they have different, if they want to collaborate, then you can share a few configuration options, and now your organizations can share information, and each organization has the ability to provide control and maintain control and access to what the different organizations can view.
Thank you.
Let's thank the speaker again.